Hello everyone, in this video we'll be solving problem 160, intersection of two linked lists. The problem statement is we are given two linked lists A and B which intersect at a particular node that says C1. We need to return that C1 node. We are given few constraints in solving the problem, and as a follow-up, the problem statement is asking us to write a solution that runs at O of m plus n time complexity and only uses O of one memory consumption. So let's start with solving this problem in a naive or a basic approach, and then we'll think about how we can optimize it to match this requirement. The simplest solution that I can think of is to iterate through, let's say, list A and save its corresponding values in a hash set, and then start with the second list and compare if any of the particular values exist in this hash set. For example, if we are iterating through list A and saving it to this hash set, we'll get all the corresponding values here. And then when we start iterating through B, we'll compare the value of each node and confirm if it exists in the hash set. If the value exists, we'll return that value, else continue the iteration until we encounter a null. If we apply it to here, B1, B2, B3 does not exist in the hash set, so we'll do nothing. Once our pointer is pointing at C1, which exists here, we'll return that node as is and stop the iteration. With this solution, our time complexity is O of m plus n, as we first iterated through A, whose corresponding number of nodes is represented by m, where n represents the number of nodes in list B. But our space complexity is O of m, as we are maintaining the hash set of the values in list A. Now let's think about how we can improve this solution to match the second requirement of the memory consumption. If you notice here, as we are iterating through list A and list B, one sure shot common node is going to be null. Both of these iterations will end up pointing a null node or the value 0 once we are at the end. And if we start with a two-pointer approach and simultaneously update them or increment them, both of these pointers will point to null eventually, but it may not be at the same time, because there are 5 nodes in list A while 6 nodes in list B. So they will get to this null node but at different times. If we add the total number of nodes in list A and list B for the iteration and let it run through, both pointers will reach the null node at the same time. For example, there are a total of 5 nodes in list A, and if we let the pointer A continue the iteration on list B, 6 more nodes will be added to the collection, making it a total of 11. Similarly, for pointer B, it will start with 6 nodes in list B, and then if we move the pointer to point at list A, it will add 5 more iterations for nodes in list A, which will give us the total of 11 nodes to reach null node. If they both are pointing at the null node after 11 iterations, it means that they will be pointing at this C3 node at 10 iterations or at iteration number 10. Taking a step back, both of the pointers will be pointing at the C2 node at their 9th iteration and point at C2 on their 8th iteration. As both of these pointers are pointing at the same node exactly at iteration 8, we can write a while loop which will continue the iteration and compare the corresponding values what these pointers are pointing, and if the value matches, we can simply return that node. So with this solution, we don't have to maintain a collection. Let's do a couple of simulations to understand how will this work in action. Starting at PA and PB pointing at the default or the starting position of node A and node B, A1 and B1, are they equal? No. So we'll continue further. A2 and B2, are they equal? No. So next for A pointer is C1. For B, it's going to be B3. They are still not equal. So we'll continue the iteration. So we'll continue further. C2 and C1, C3 and C2. As there are no nodes after C3, we'll update the A pointer to start pointing at list B. So after C3, the next node will become B1, and here after C2, it's going to be C3. They are still not equal, so we'll continue. A pointer will now point at B2, while the B pointer, because it is at the end, now it will move up and point to list A. So its next node is A1. They are still not equal. So looking at the next node, which is B3 and A2, still not equal. And the next node after those two are C1 and C1. They both are equal. So we'll return this node. With this solution, our time complexity is still O of m plus n, as we are iterating through both of these list nodes, and the space complexity is improved to O of 1, as we are no longer maintaining the values in a hash set. I hope you were able to understand this solution. Let me show you how we can implement this using C#. Here is my C# solution. I start by initializing two pointers A and B, which are pointing to list A and list B respectively. I then start a while loop until A is not equal to B. If they are equal, then I'm exiting here and returning the node A. If A is not null, then I'm changing or incrementing the pointer to point to the next node. If it is null, then I'm updating the pointer to point at head B, which is list B. I'm doing the same thing on the next line for B, checking if B is not null. If it is not null, then I'm updating the pointer to point to the next node in list B. And if it is null, then I'm updating the pointer to point at list A. This solution, when submitted on LeetCode, beats nearly 98% of the submissions in terms of runtime complexity, and in terms of memory consumption, beats 100% of the submissions. Thank you for watching this video. I hope you were able to understand this explanation and the source code. The link to the code is available in the description below. Feel free to check that out, and I will see you in the next one. Thank you.